Hello and welcome to another episode of Maths with Mrs. Banks, where we make maths fun and easy to learn. And in this video, we're going to look at another question from the November 2023, this time the Eastern Cape Provincial Government, for mathematics grade 11 functions. And the functions we're going to focus on is the hyperbola. Now question 5 goes, the diagram below shows the graph of f of x equals to a over x plus p plus q, which is the standard format of the hyperbola. The asymptotes of f intersect at the point -3, -1 thing, and f cuts the x-axis at x equals to -5. Question 5.1. Write the value of p, the values of p and q. Now the values of p and q are very easy to figure out now that we know that the point of intersection of the asymptote. So 5.1, the asymptote point of intersection is -3, -1. Therefore, for x plus p, right, x plus p will be equals to, right, so therefore x equals to -3, meaning that x plus 3 equals to 0 is the x plus p. Therefore p equals to 3 and q equals to -1. All right, those are p and q. Therefore the equation so far is f of x equals to a over x plus 3 minus 1. 5.2, next question goes, determine the value of a. Now in order to determine the value of a, we substitute any point on the equation, on the function, and the point -5, 0, which is the x-intercept, is part of that. The point -5, 0 lies on f. Therefore we substitute this point where y is, we put 0, the y coordinate, and then where x is, we put the x coordinate. So that will be in bracket -5 plus 3 minus 1, and we simplify. That is a over -5 plus 3, that is -2 minus 1. Take the 1 to the left hand side, a over -2. Multiply both sides by -2. Therefore 1 times -2 equals to a over -2 times -2. The -2's cancel out, and on the left hand side we're left with -2 minus 2 equals to a, and that is the value of a. Therefore the equation is f of x equals to -2 over x plus 3 minus 1. Does it make sense? Definitely it makes sense, and let me show you why I say it makes sense. Notice that the equation, the graph, is on the second and fourth quadrant. That indicates that your a is negative, so yes, our value is correct. 5.3, hence or otherwise calculate the y-intercept of f. Now that we know what the equation is, we can simply calculate the equation of the y-intercept. Let's say the y-intercept, the y-intercept of f. Right, that's 5.3. The y-intercept, to find the y-intercept of any function, we make x 0. So now therefore, let's go. F of 0, which is the y-intercept, will be negative 2 over 0 plus 3 minus 1. So we substitute that, therefore y equals to negative 2 over 3 minus 1, all right, which is equals to lowest common denominator, minus 2 minus 3. That gives us minus 5 over 3, which is negative 1 and 2 over 3. Didn't have to do all that, but I just wanted you to see this in all versions. So therefore, this gives us the point point 0, negative 1 and 2/3, negative 1 and 2/3 is the y-intercept. All right, 5.4. Write down the domain of f. The domain is any value of x that is valid in the equation. That's what the domain is. Now, if you go from left to right, you will see that all values of x on the number line are valid except for the point where these two asymptotes meet, and the point is negative 3. So therefore, this is how you write the domain. The domain is x is an element of real numbers except for when x is equals to negative 3. So 5.5. Determine the line of symmetry of f with a negative gradient in the form y equals to mx plus c. Now, the hyperbola has got two lines of symmetry. All right, I'm going to list them all. The hyperbola have got two lines of symmetry. And the first one is the one with a positive gradient, and the second one is the one with a negative gradient, and it's got this equation. Now, to find the information that we need to figure out what C2 in this case, because this is the one that we're looking for, we need to substitute the point of intersection of the two asymptotes. Substitute into y2, so we can find what that value is. Therefore, where y is, we put negative 1, and where x is, we put negative 3. Plus C2, clean it up. Take the 3 to the left hand side. Therefore, meaning that therefore the equation of the asymptote, therefore the equation of this axis of symmetry with the negative gradient is negative x minus 4. If you were to find the equation of the line of symmetry with a positive gradient, you will do exactly the same thing. Substitute that point of intersection of the asymptotes into y1. 5.6. For which values of x is the graph positive, greater than or equals to 0? Greater than or equals to 0. In other words, where does it lie above the x-axis? That's what that means. Now we need to know exactly where it cuts the x-axis so that we can figure out where it lies above and below the x-axis. So you take a ruler and a pencil, draw a line here at the point where the x-intercept is, where the graph cuts the x-axis, and then look at the graph. Where does it lie above the x-axis? Now notice we've got that line of the asymptote. The graph is invalid there, so now here we go. Notice that between x equals to -5 and this point, right, where the asymptotes meet, that's where your graph lies above the x-axis. To the left of this, it lies below the x-axis, in other words it's negative, and to the right of this point it lies below the x-axis, meaning it is negative, meaning that f of x is greater than or equals to 0 when x is equals to n including -5 between -5 and -3, including -5 but not including -3, because there it is an asymptote, meaning that it's undefined there. So your x is between -5, so that was 5.6. F of x is greater than or equals to 0 when your x is between -5 and -3, including -5 but not including -3. And that's how you write that. The last question, 5.7. Let's go. Describe the transformation of f to g given that g of x equals to 2 over x minus 1 plus 1. Alright, here is the transformation. Alright, if this is what you now have, alright, that means before your graph was shifted 3 units to the left, alright, now it has been shifted 1 unit to the right, because our p equals to -1. This means 1 unit to the right, and then our q is equals to 1. That means it's been shifted 1. It's now 1 unit up, 1 unit up, right? But let's see, compared to this graph, all right, it was 3 units to the left, so that means it was shifted 3 plus 1 units to the right. Therefore the graph was shifted 4 units, right. And because in the original it was 1 unit down, so now it's all the way to +1, meaning it was shifted 2 units up and 2 units up. In general, your P shows shift left or right, and your Q shows shift up and down. Now if Q is positive, that means your graph is shifted up. If Q is negative, that means your graph is shifted down. But with the P's, if P is positive, that means your graph is shifted left. And if P is positive, negative, then that means your graph has been shifted P units to the right, and that's how the shifting works. And this is the end of the question. We've come to the end of this video. Thank you so much for watching. See you in the next one. Bye-bye.